Good afternoon, Professor. This is my second assignment of MMIC IPD, and today's assignment is of chapter 1 from IPD MMIC book, and I have make a presentation what I have gone through in first chapter and what I have understood in that book. I'm going to present today. Okay, in this first chapter is all about review of IPD technology. In this, I have studied that what are the backgrounds. First topic was what are the background and overview of IPD. In this, important is like integration of RF active and passive device can reduce the size of system. It can also improve their performance also. Jack Kilby is defined this as an integrated true transistor and resistor onto a single chip. In this figure you can see compound semiconductor. In compound semiconductor such as gallium arsenic and in GAS and indium phosphate used for radio frequency system integration, which process high electron mobility and good insulation properties at high frequency. However, this GAAS technology is relatively expensive, and nowadays this most circuit are integrated system using this GAS offer the chip, and IPD has attracted significant attention due to a constant need of handheld wireless device to further decrease in cost and size and increase in functionality. These are totally integrated and mounted on semiconducting substrate. In this IPD containing passive circuit component which has resistor, indicators and capacitors. Next is continue of this background and overview of IPD. In this application for IPD, like whole passive device and front-end modules of a mobile system. In this mobile communication system, the functional blocks such as splitter, learner, duplexer, transformer, and directional coupler and power divider uses IPD technology. And in the performance of this wireless mobile and communication system relies not only excellent design but it also on a characteristic of material has been used, and high quality and low cost fabrication is used in for development of this such technologies. As you can see in this the graph chart also, the blue shaded part is digital and mixed signals, and red is for RF and gray is for LED lightning, and the purplish color is for ESD EMI protection. In this it is a highest growing sub segment, you can say RFID technology. This have optimal proportional and flexible system in package configuration at lowest bill of material cost. In this and as you can see in this graph also, this graph has forecasted of uh, thin film of IPD market, how the market will be, and how according to per functions. And this market has spread most electronic sectors, and ranging from low volume to massive market business in aerospace, military, medical, industrial, lighting, communication, and personal computer applications. This is uh, in this you can see discrete passive solution and integrated passive device solution. In this basically uh, in this IPD, this has combined for a massive component into a single package. uh, IPD has been increasingly using this GAS thin film substrated rather than silicon like semiconductor device, which is very poor characteristic and difficult to tune also. And wafer level packaging, that is WLP, yielding minimal size and low cost. And this IPD transmission line, indicator, capacitor, functional passive device with the loss of minimal crosstalk is has advancement for active transistor technology. In this IPD, 50% smaller and 70% thinner, and require 50% less printed circuit board PCB area compared to discrete passive device. Next is, in this technology is ideal for product like mobile phone manufactured at high volume and need to be small in size and low in cost. Another method is integrated passive device, which combines them at WLP steps, and which establish multiple metal passive layers, and the passive components also built directly onto die between the chip and the first level interconnected shoulder pump. And as you can see in this figure, first figure is about flip chip type, next is wire bond with flip chip, uh, and the second one is wire bond type, and third one is wire bond with flip chip, and next combination is wire bond with wire bond, and fifth one is flip chip with flip chip, and sixth one is flip chip with the embedded chip. uh, uh, in order to increase the package density, this has possible to combine this basic WLIPD types into stacks. This is various TF-IPD application. In this scale of frequency 10 to 80 gigahertz, uh, according to frequency, this uh, particular application has been made. As you can see in this picture, wireless LAN is made using around 5 gigahertz frequency, handset, global positioning system. Broadcasting can be about greater than 10 frequency, 10 to 20 frequency gigahertz, and earth observing satellite fixed and mobile radio frequency uses 20 to 50 gigahertz frequency, and for satellite communication also, for automotive radar they had used 60 to 70, 80 frequency gigahertz. This is large increase of microwave application using integrated passive device technology. This is application of IPD product. In this you can see PA modular cellular antenna, PAWC, DMA duplexer, and uh, there is a WLAN to 2 GB to 1.5 GB antenna, and display baseband memory application processor, GSM WCDM transceiver for communication, and many other uh, product also has been IPD product also has been used for this WLAN FEM, WLAN duplex coupler, 2 GB to 5 GB antennas, and HDMI wires and speakers, camera, and these are all application of IPD products. In this uh, 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 IPD continue to evolve. This becomes available that provide vertical interconnection within IPD application like silicon interposer, which increasingly significant market, and the decoupling loop, the distance from capacitor to the decoupler IC will be considerably reduced, coupling effect that resolved for power integrity issues. And in this IPD are the bridge platform between front and back end for semiconductor industry, and it is small cost issues with IPD have slowed their adoptions, and for need this better electric performance, smaller size thickness advantage, as well as their thermal reliability performance to compete with the mainstream of passive industries. In this next topic uh, within this chapter was organization of this book. Uh, in this process for manufacturing, GAS based on IPD has been optimized, and features of fabricated device and performance, yield, and reliability of integrated passive components has major role in development of IPD process. In first chapter, we will going to see general introduction and review and advantage. As I said before, advantage, packaging method, and applications of mobile phones, application of TFIPD app mobile phone. There was a range scale 10 to 80. I told in first chapter, and the second chapter will considered as a topic such as LTCC, thin thick film, IPD different substrate, um, IPD environments, that component layout design and their problems during development, and traditional process and previously developed process also mentioned in this second chapter for manufacturing this IPDs, and the three board classes required for conductive, resistive, and dielectric. For conductive films needed to carry current with minimum voltage loss, and bottom plates are capacitor and spiral bending of a planar inductor, and the wide variety of material could be used, which ranges resistive and ceramic metal, non composite, and dielectric film uses foam integrated capacitor, vast array of material with wide range of uh, dielectric constant are feasible, simple unfilled polymers, low value capacitor metals oxide. And third chapter will going to cover GAS based IPD fabrication process, which enables integration of discrete passive component using into an IC. With this fabrication is is highly competitive in terms of performance, reliability, cost, and yield. Greater precision resistant of thin film resistor, which change the bottom metal manufacture process. COAU electroplating, um, and further increase of electric and mechanical properties, and a good sheet of resistance from 24 to 35 to 26.16 ohm square is achieved, and high spiral inductor Q factor 11 yield 1 air bridge type inductor and double air bridge type inductor presented in this chapter 3. And in fourth chapter we are going to study about the practicals of IPT design flow, wireless local area network, and using low pass filter and long term illusion band pass filter, balloon, and LT power divider, RFDI coupler, and their basic theory, circuit design, simulation, measurement result, and performance of MMIC fabrication. Chapter 5 we are going to study about equipment used for setting this, and on wafer measurement, introduction of this process control monitor PCM, and power handling measurement are reported. And in sixth chapter we are going to conclude about the achievement and summary and production about the result of design and fabrication, possible solution, and some suggestion for future work also. Thank you for this for the day, and this was I have covered and I have studied in first chapter, and